recording.
Okay, sounds good. So let's see. Uh, what shall we do? I I wanted to kind of sketch out the idea of how to make salsa be a bit more on demand. So I guess the beginning thing is to, or not salsa, sorry, chuck. The beginning thing is to look at what the heck it does now, right? So now we have. Actually, why don't we start from the test just to bring it back in cache. So one of these tests, somewhere here, invokes a lot of macros. Where do they actually call code? Solve goal. There we go. One second. So, okay, right. So when it runs, we call parse and lower goal. So we have the parser, which parses the input text, and then we call this lowering thing, which does a lot of stuff. Is this the code that runs? Probably. No. Can you remember? Can you remember? Okay, whoever just connected with a tiny screen, you have to like grow your size. Okay. Lowers. So let's see. Right. So lowering begins. It's like two phases of lowering. Right. The first one is, I think, where we kind of create the IR or something like that. Yeah, this is it. So we go over the AST. We go through and make random IDs for everything that we find in the AST, and build up some maps stored in the environment to have, like, for a given structure, some information about the structure, right? So mapping from its ID to, like, basically this sort of thing. Let's take a look. Like so for a given struct, we might store the self type, the field types, and all that kind of stuff. So this is meant to be, I think this phase can, at least in Chuck, could remain sort of monolithic. But actually, let me step back a second. I just realized I wasn't. So the first question is, why would we want to change anything? The motivation here is, I think I said it in the meeting, but that right now we have this lowering phase that translates all the chalk IR into sort of lowered program rules, like prologue clauses, in one swoop. But if you have specialization, then that's not going to work, because sometimes you have the need to actually execute queries and things, figure out the relationship between traits. So let me give an example. So I think you might have like trait foo and trait bar, and then we might have maybe bar implies foo. And then we want to have some other family of traits. Right, and we have implement for all t that are foo, and implement for all t that are bar, might be for t. And the question is, how can you figure out like the relationship between these two impulses? Is one more specific than the other? To really be a good example, I have to have a method or something. And the answer is yes. The second impl, bar, is more specific than foo because bar implies that foo must be true. But how do we know that? The way we know that is we do some queries. Basically, we ask stuff like, for all t, if we know that t is bar, can we prove that t is foo, for example? And the answer would be yes. But if we say, okay, well, what if we know that t is foo? Can we prove that t is bar? And the answer would be no. And so by this, we kind of figure out that one impl is more specific than the other, because knowing the where clauses of one satisfies the where clauses of the other, or lets us prove the where clauses of the other, and the inverse is not true. So does that all make sense so far? So if we're going to evaluate this question, though, down here, then we have to have the rules for foo and bar available to us. And the tricky part is that basically, in order to build the rules for my trade, we need the rules for foo and bar. And right now, the setup doesn't allow us to do that, because we get the rules for everything all at the same time. I don't actually know what the chalk rules for specialization exactly should look like, so that's another question mark, but I know they're going to require some information about, at least I suspect we're going to require some information about this. Usually it'll probably be something like, if you want, basically, if we want to know which method applies, we'll have to know, for example, here we would say, this version of method only applies, ultimately if t is foo, but t is not bar, and stuff like that. So we're going to have to set up some rules that make those tests. But it may be that those now that I think about it, it may be the case that we never, the only thing we need to know, is this true? It's probably not true. I was going to say it might be the case that the only thing we need to know in order to establish the relationship between impulse, the specialization relationship, is whether or not a trait is implemented. And that sort of doesn't, in some sense, doesn't care which one is more specific, because it's implemented if it implements foo or it implements bar. But actually, I think that's probably not true, because there would be other more complex things you could do still with associated types and so on. Anyway, I'm not exactly sure if we need to do this change to make it on demand, I guess, but I think it's likely we do, and I'd still like to do it. At the end of the day.
Yeah, I was going to ask why this relates directly to specialization. Maybe I missed that part, but during lowering, you need to be able to process the rules. During lowering of a specialized impl, you need to be able to already have the rules.
I think that's going to be true, but that's the question, I guess. I think that in order to make the rules, that if you have an impl that has default, basically, in order to for it to know what rules it produces, it has to know about the other impls that specialize it, so that it can check that they don't apply. But now that I'm thinking out loud, I realize that might only be true. There's this distinction in specialization between the reveal phase and the non-reveal phase. The reveal phase is during type checking, basically, where we say that's the point where you get to learn. If you have something that's potentially specializable, you don't actually...
I'm sorry, you broke up at the...
Let me adjust my example 1 second to make it a little easier to talk about. So there's this distinction in specialization, what we call the reveal phase. And the idea is something like this. Let's suppose... we'll do it like that. So now we have this associated type, right? And it says here that if, for some type t, So for some type t, basically if t is bar, then t some type is bool. Agreed? But if t is foo, but not, or like else if t is foo, then it's U32, right? And the else is important because if t is bar, it is also foo. So, so this is true. However, you don't get, well, we have these two phases where basically the question is, when do you get to know exactly what t : subtype is? And so imagine I have some struct x where foo, which implements x but not bar. During type checking, we don't allow you to know that x some type. We basically don't let you know what it is exactly. The idea is if it's something that could be specialized, then you don't know exactly what it's specialized to. This may or may not change in the future, but one of the reasons for this would be maybe it'll be specialized in the future, like in a future version. There, if we added more impls, maybe we would add an impl. Like we know that x doesn't implement bar now, but do we know that's true for all time? You could imagine using similar rules to the rules that coherence uses, which at the moment, though, the RFC just said that during type checking, you never get to know what some type is. You always have to treat it as like an abstract placeholder. But then there's this reveal phase, which is code generation. And in the reveal phase, we know exactly what x some type is, because we need to generate code, so it's time. In short. And there's similar stuff applies. So for example, if you have impl-trait, it's a similar thing. If you have a function foo arrow, this is sort of unrelated but related, right? If I have something like this, at compilation, at type checking time, I don't know what type the return value is exactly, but I find out at code generation time, I have to know. And Sunjae, if you remember from coherence, I feel like there's a relationship here too. But well, when we wrote up the coherence rules in Sunjae's internship, we had this notion of what do we call it? Basically, asking a kind of similar there was a similar situation where there are things you don't get to know. In this case, it would be negative information.
Are you talking about downstream types?
Yeah, but there was like for when we were in the open world, or like the closed world, we had a name for that, right?
Compatible mode?
Compatible mode, yeah, that was it. Well, basically we used a similar trick. So if you have basically, do you get to know? The question would be, when do you get to know that like t : foo is not implemented versus might be implemented, and it has to do with negative reasoning, and it's a little far afield, but it's a similar sort of thing where we have these notions. So.
Yeah, like basically the idea was that you have some rules that are only introduced if you have a specific predicate called compatible, and if those rules exist, then situations like this become ambiguous instead of having yes or no answers.
Yeah.
Or that's the summary.
Right. I would say you basically make rules, but as part of the rule, you require this extra thing. So like one way we might encode this would be to say, so the way we encode, and by this I mean the specialization example, but we have this like normalized to or something like this, right? That we can say, does t as my trait : some type, we might say it normalizes to bool if, or to U32, let's say, No, let's say equal. No, 32. If reveal mode is true and t implements foo, and then sort of not t implements bar or something. This probably is not actually how we'll do it, but something that is equivalent to that. Or I guess not. And part of the premise here, yeah, basically that. Right, and the main, I guess this is my point. In order to know what goes in this not, oh, I think I did this. Yeah, in order to know what goes in this not, we have to know about the relationships of foo and bar. So we can't make these rules without having done some tests to establish the relative ordering. Yeah. So I'm gonna, right now, if you try this, an example like this in Rust-C, what you'll find is you get an illegal, or rather, this example should work fine. But what you may observe is that you can have a cycle here, right? You could say, like here, my trait requires us to know the rules for foo and bar. You could make some impulse for foo and bar that require us to know the rules for my trait in the same way. And if you did that, that would be bad. So like I could do this. I don't know, something like that. And now I have this specialization question I have to resolve. What will happen in Rust-C if you do this is you'll get a cycle error. And that's what I would expect to happen in Chalk as well, for the time being. So, okay, that's the what to do. Now, how did I want to do this? I figured we could adopt Salsa, which is my version of the Rust query system, as a standalone library. So it seems nice because it's kind of like what Rust-C does, and maybe eventually Rust-C will even use it or some variant of it. If basically, maybe Rust-C will eventually use some external library, and then Chalk could use the same one. But the idea would be to set up some kind of queries that drive execution. So if the current thing works like, if the current Chalk structure is sort of parse to get an AST and then lower the AST to Chalk IR or something, and then lower the Chalk IR or generate rules from Chalk IR. In a forward kind of way. Then I think the new structure would be more like more demand-driven, meaning we would start with what we want to do. So to solve a predicate, we have to, parse the program, or rather get the rules for the program. And to get the rules for the program, we have to get the lowered Chalk IR. And to get the lowered Chalk IR, we have to parse the program, and so on. And this would be the main thing, is that in here we would probably actually have an intermediate step that would be like, for each trait in the program, get the rules for the trait X, right? And the reason we break that up is that this allows, in some cases, get the rules for other traits. This allows us to like have a little cycle here where I need to give these names, where this invokes query C again, but for different traits. Yeah. So far, so good. So let's see. Main thing I wanted to remind myself, because I don't remember, is somewhere we run coherence, right? Like, does anyone remember where we do that? maybe at the end of this lower function. So like lowering, I guess it's here. Perform orphan check. Yeah, record specialization. You can see we sort of did some of the work. This is the current lowering logic. And where do we actually build the rules? Here we make all this stuff. Add default impulse, record priorities. What does verify wolf? No, not verify. Perform orphan check do. Record. I guess that this end contains all the rules, right? I think so. So when we have a program, the program itself just has like information about, it's almost like an AST or something. It doesn't have actual rules. And I think those rules are created in the program environment, maybe. It's been a while. Where is this function? There it is. Yeah, here we go. So it looks like we're kind of constructing that at least a couple places now, right? So for example, in order to solve the well-formedness requirements, we lower the rules once. Then again, when we're performing the orphan check, we call self.environment. And then probably somewhere else, because where we actually do the two. So that's kind of silly also, but that's okay. It's the same result each time. It's a good fit for the query system actually, which will cache this. I mean, I guess we could sort of do a first pass, I suspect, where we just make really blunt queries. Like we don't actually do the actual goal of enabling fine-grained lowering, but we just have some really big queries that are like, give me the program. Basically, this one, give me the lowered program. And that will say, okay, give me the results of the orphan check, verify well-formedness, or even more, we just have exactly one. It just does the lower step. And that'll just put in the infrastructure kind of without doing any of the actual interesting work. That's probably a good starting point.
So Nico, when we're doing just the specific steps needed for a query, do you always want to do checks like well-formedness and stuff for every single query?
I don't know. I mean, if nothing else, it's kind of annoying sometimes to have all those checks when you're writing tests, because you'd like to write some sort of targeted tests and you have to add all this other crap. I don't know. Or else you get like unrelated errors.
It's repetitive if you do it in every single level, right? Like you only need to check well-formedness once, but if we don't do it properly, we'll end up doing it every time. That's what I'm asking about.
Yeah, I think it'll mostly. I imagine it will work out in sort of by the nature of you'll have some query that says give me the program environment give me a program environment that is ready, that is fully formed and ready to solve stuff, a complete environment. And that will, part of that, one of the steps to making a complete environment will be running the well-formedness check. Right? But internally it may have several steps, but and it's not that each of those steps would run the well-formedness check. If that makes sense. Though,
yeah, that's what I was asking about. Thanks.
I do think, though, probably what will happen is that the well-formedness stuff is not there's no dependency. Like it can always be run at the end, right, Alex? It doesn't have to like be run in order to make the rest of the rules. So yeah, that's how I think it would. All right, so I guess I need to give a quick intro to Salsa while I'm at it. So Salsa, the idea is kind of like the I'm just gonna add a dependency here. It's kind of like the compiler's query system, but a little different. So let's see. The idea is that you define something called a query group, and I guess I'll make a module for it for now. Why not? And a query group. Let's see. Now I have to look up my own docs because I don't remember what the syntax is. Check. Oh, so just for reference, if you're all interested, I'm looking at this page, and in specific, I'm going to jump over to this hello world example here. So a query group basically defines a set of queries. It's not supposed to be the full set necessarily. Like the idea is that the compiler currently has this giant macro where you specify every query of the whole system. Salsa is different in that it has different groups of queries, and they all get combined at the end. But we'll probably only need one group anyway because it's not that complicated. And the idea here is you have, right, so a query group is represented by a trait. Currently, are we using Rust 2018? Didn't somebody do that recently? Yes. Currently, I have some ideas on how to change this interface, but I'm trying to prevent myself from talking about them, even though I want to. And instead, just present it the way it is. But currently, it would extend this Salsa database trait, and the database is basically going to be where all the data is. For each, I'm assuming some familiarity with Rust's queries, but I realize now maybe that's not a good idea. But basically, we'll have these. We'll see as we go. We have these functions. They're going to have memoized results, and that's what the database stores. So the first thing we need to do is define like what is the input, and our test. Where was our test? Where is the thing? Here it is. So you can have some inputs in Salsa. They are basically like the starting points of the system. So Salsa also enables incremental recompilation and so on. So this would be, for example, we probably want our program text. I guess we'll just do it like this for now. I don't know. So when we define this function, we're saying this is one of the, yeah. So this is a macro, so it's not obviously really Rust syntax. But we're defining the input to the system. So anyone's going to be able to ask the database for the program text, and they will get back a string. And the reason it's called an input is that you can change it, and then that's a new incremental revision. So you can say, I did all my compilation with this program, here's a new program, re-execute, and it'll reuse memoized values where appropriate and throw out memoized values where something is changed. We're probably not going to care about that very much for this purpose, but maybe someday, I don't know. So if we want to do this like in its simplest form, then I imagine we would have the program text, and then we'll have some query that's like lowered program. Something like this, I guess. Doesn't have to be in, I'm putting everything here in arcs. They don't have to be in arcs, but you do want something that can be cloned relatively cheaply. So it's usually a good idea to put it in an arc rather than having like a big vector or something. Because each time you invoke the query, it gets stored in the memoized tables and stuff, it's going to get cloned. So this is the basic idea. We have one input and one, this is called derived queries. there's one other thing that Salsa requires you to do, which is for each of these queries, there'll be a type. So you have to give it a name. Okay, that's going to be our program group. Very simple so far. Then we have to define a database, but let's do that. Let's do it. I'll do it here in a different module. So the database is where the actual data is going to be. So the query group, remember I said there can be many of them in the system. Database is going to pull all the groups together into one. This is sort of boilerplate, copying out of this Hello World example. But the database can have other sorts of fields, but mainly it stores a Salsa runtime, which has the actual data. Yes, okay. And the last thing, this is where you list out so you have to list for the given all the query groups that this database should implement. So in this case, we need, and annoyingly, one of the things I'd like to change, but for the time being, you also have to list out the queries within those groups. And basically for each of these queries, there's going to be some storage allocated and so on. So now we're almost done. The only thing we've done a lot of the boilerplate. There's something we have not done, which is defined the queries, what we call the query providers in Chalk, or in Rust, basically the code that's going to run when you use these queries. But that's okay. The compiler should tell us about that. Does this make any sense to people? Questions? I'm hoping it'll all become clear when it's all put together. Every time I talk about Salsa, I realize that I need to work on how I talk about Salsa. But I don't know.
I mean, I understand every word you said, but I don't know if I'm understanding the point you're trying to get to. Do you have a point you're trying to get us to?
I'm trying to get to the point where we're actually... Yes, I do. I have a point. The point is going to be, I think we should be able to, before the hour is up, rewrite Chalk so that the lowering happens inside of a query, just one giant query that does all the work instead of a function, which is basically pointless, but can then be refined into smaller queries. That's basically the idea.
Okay, then I do understand what you're saying. Cool.
Okay, so now we're starting to get errors. That's fine. That's expected. First of all, this needs to be query. Okay. This should be, I guess, use crate. Wait. Oh, this got. Oh, that's lame. Or what? I guess it's Rust IR. Thought that was in another crate. Yes, Rust IR. Okay, that's fine. No. Okay, so this is the interesting error. So when you have to define we haven't actually defined this lowered program query. You don't have to define inputs because they get set by the output, but the derived queries like lowered program actually do have to be defined. And the way that you do that is basically to write a function. And these, as an aside, I didn't mention it, but you can have parameters here, like, I don't know, x if you're 32. And those become the keys to the query. But we don't really, in this case, there is just one lowered program that's like the master program, so it doesn't really need any key. When we want to, in the future, as we add more queries, some of them will no doubt have keys. But, okay. And so this one is just going to basically do, where were we? It's going to basically do this. Parse and lower program. Right, and so really it can just do this, actually. We're not using it yet for anything, but I probably have to import some stuff like this. See what happens. Oh, right, okay. So now we need the text. So when you call parse program, it needs to have the input text. And we have that. It's one of the inputs. So we can just invoke this. Let me bring this up so you can see it. We just invoke this method like that. And now we're getting the input. And behind the scenes, when you invoke another query or an input, Salsa is going to track the dependencies between them. But that doesn't matter to us right now. So something like this should work. Solver choice. Okay, so there's a parameter we can put in here. I think this is just some email. Yeah. Okay, that's annoying. This needs to be public. Oh, that's annoying too. So it's complaining because the error was that this type doesn't implement EQ. The reason it would have to implement EQ is that it's part of this result here. And we like to, Salsa wants to compare the prior result with the new one to see if it's changed as part of the incremental mechanism. I think there's a way to, well, for now we'll do this, which I think sidesteps that, but I'm not. Okay, so what a volatile does is says basically just re-execute me all the time. So it sidesteps the EQ requirement, but there's now a stupid clone requirement. God, damn it. I don't know. I guess I can put it in an arc or something.
Yeah.
I'll just arc.
Yeah, right.
Okay. Lame. Oh, but now question mark's not going to work. This is going to be annoying. Stupid. Who was it that opened that issue saying we should get rid of error chain? You were correct.
It's Sanjay. For now, it was.
So true. I wonder how. It's probably really hard to make this like. I mean, there's like no reason for it not to implement clone, right? Basically, it's just a bunch of data.
I think that's why you switch to the Fable type, where the error type is just the unit type.
Yeah, but then you don't get any like data out of it. All right, fine. I'm just gonna put it in arc. It's cool. It's no big deal. It's fine. Fix me arc of result is only needed because the error type is not clone. Also this, fix me only volatile because the error type does not implement EQ. And then we'll just do something like this, I guess. and I probably have to opt into some feature gate. I didn't think they had to be send. Oh, it's why is that? It's because I'm using arc. Whoa, no. I mean, it's not wrong. I just didn't think you had to be send and sync to be. Okay, here's what we're gonna do, because this is too freaking annoying. I didn't think Salsa required things to be sendable. I still don't think that's true, so I'm not sure why, but obviously it is at least sort of true. Maybe it's one of the other types that does, I don't know. But okay. Now I just have to like map this error to be like whatever. It probably implements display, I guess. What was it called? It's getting so close. Oh. I guess it doesn't have to be an arc. Yeah, I'll leave it as an arc. What is this? Yeah. Oh. Whoa.
Yeah, the arc needs to be the on the result of lower, right?
Yeah, but shouldn't .map put it there? Oh, you know what the problem is? This is the problem. It's because try is like okay wrapping. Okay. Now it compiles. I'm not using it for anything. Man. Oh dear God. Okay. I feel compelled to write something there. Can't just leave it like that. I guess it would be easier to do this, at least.
Yeah.
And it's still bad, but not as bad. Okay. So now we should be able to convert this test util to do something like, this is so silly, but that's okay. Use create db chalk. What did I call it? I think I gave it a really dumb name.
Chalk database thing? No?
Just called it database struct. I think we could be a little more. Why don't we call this chalk database, and we'll rename the other chalk database. If we call this lowering database, then we'll call this database struct chalk database. It just has to be lowering. So now I can do chalk database default database dot lower, what did I call it? Lowered program. Lowered program, or I have to set, so the first thing is we have to set the input. No, where am I? Also something I plan to change in Salsa, but that's okay. So we would, to set the inputs currently in Salsa, you have to use this method called query mute. So one second, let me just, so if you remember oops, wrong module. Stop. If you remember, we created this type called program text to represent this query. So what we need to do is you go query mute program text dot set. Since this is sort of the like unusual thing to set inputs, it's a little bit awkward. That's the current API though. And then we should be able to just do this, and it will almost work, except this is promising of this. Maybe I can just change this to result string.
Arc program, right?
Oh Lord. Whoa, wait. How did that build? That's really suspicious. Surely this is not right. Yeah, okay, that's what I thought. I'm not building the test code. That's the... There's no way. Well, what's happening now? Okay. This is also really irritating.
Not found in the standard.
Come on. Use standard prelude. There's got to be a better way than this, right? But I don't know what it is. Okay. Now we're getting some fun errors. So this method just means I have to import the trait. That's all. And I probably have to import this one too. This takes a key and a value. There is no key, so it's just unit. Now you're duck. What is this one? I'm just like not even reading what the error is, really. Oh, you know what? We're putting it in an arc here. And it's already coming in an arc now. Are we always unwrapping this result? No, I guess not. This This looks suspicious. Probably true. Looks like it was a good idea to put the program in an arc. Everybody else does it. I'm kind of astonished how many people call this function. A lot.
Mhm.
Can we get these deprecation warnings off? They're really irritating. I guess just allow. Maybe like this. Is that gonna work? Probably not. It's probably gotta be like. So it's a little coarse. That's okay. All right. So sweet. Well, I will open the PR with this, but did that all make sense now? What Salsa was trying to do? I guess the next step would be to, start basically. Yeah, I realize you can't see where I'm going. Start breaking down this. So, like, the easiest thing to do would be to take this parse program and pull that into a query, and then break down lower into a query and so forth. But I'll push that later. Thank you all. We'll chat more on Zulip, I guess.
Hi.